In this video, we are going to talk about outliers and the methods to deal with outliers. So first, let's start by what are outliers? Outliers are abnormal data points in your dataset. What I mean by abnormal? Now, what I may consider as an outlier may not be considered as an outlier by some other person because the definition of abnormal changes from data set to data set, and it also depends on the situation. Also, there are cases when an outlier may not be an outlier. It may be an indication of an misclass, you can say limitation of your data or your model, or it can be considered as a limitation of your collecting data phase. When you were collecting the data, you were not prepared for that data point. Now, there are two types of outliers, mild outliers and extreme outliers. Now, for those of you who don't know about what is Q1 and IQR, now these are interquartile ranges. You don't need to know about this stuff for this video, but it is an interesting topic that you can search online. Now, methods to deal with outliers. I would be discussing four methods in this video to deal with outliers. The first is univariate method. This is the simplest of all the methods. You simply look for extreme values in your dataset. So, say if you have data points in which all your values are less than 100 and you observe a value of say 1000. Now it clearly indicates that it is an outlier. Now again, I am not considering that assumption that this outlier may be due to some, well, you can say, error while collecting your data. So the dependencies for this video are NumPy and Matplotlib. You don't need to know about these dependencies if you don't know. I would be teaching you along the way. But these are a must know if you want to be a data scientist. Now first let's generate some data. np.random.random generates data from a standard Gaussian distribution. For those of you who don't know about a Gaussian distribution, it looks something like this. It looks like a V, or you can say bell shape. np.random.random takes up random values from this distribution, and I'm multiplying that by 10, and I'm generating 50 values. Now, I add some external noise to this data. I add the values of 80, 95, minus 40, and minus 100. Now, to do univariate analysis, box plots are an extremely good method. What are box plots? Box plot looks something like this. Now, in box plots, you divide all your data into four quarters, Q1, Q2, Q3, Q4. And the dash here indicates the median of your data. This dash here is an upper quartile. This is where 3/4 of your data ends. This is your lower quartile. This is where your 1/4 data ends. And now these are extreme values of your data set, upper extreme and lower extreme. Now these values are calculated using interquartile ranges and there are formulas for it. Now what makes box plots useful is that it automatically classifies some values as outliers depending upon interquartile ranges. So as you can see in this diagram, this this dot right here indicates an outlier. So plotting the box plot for a generated data. In Matplotlib, you use plot.boxplot to generate a box plot. As you can clearly see, it identifies the outliers directly. 80, 40, minus 40, and 95, what the values were. Now, let's do some another example. I again generate some random data, data 1. Now, np.range generates values in the sequence 1, 2, 3, 4, 5, 6. That is, it generates a linear data for you. And now I'm manipulating a single value of 16, 0 and I make it 20. Now the original value at 16 would be 16. I make that 20. For those of the nerds in this video that know indexing, I know that it should be 15. But for this purpose, let's say at 16 we make it 20, and we plot the data. As you can clearly see, this is an outlier because it is not following the linear model of your data. But if you draw a box plot for this data, it does not classify that point as an outlier. This is because this point, as you can see, becomes part of this interquartile range. It does not cross this lower extreme and upper extreme because it is part of the data. Now to deal with this outlier, we have another method, multivariate method. Now in multivariate method, you generate a you generate a model using your entire data set, and now you compare the values generated by a model and the original values. And if the difference between the original values and the values generated by a model is greater than some threshold, we consider that as an outlier. So for this example, if you draw a linear line through it, as we know the data, it would clearly go through all these points. Now what you can observe is when I draw a line through these points, the distance of these points from the line would be approximately zero. But when this line reaches this outlier, the difference suddenly increases. And this is a basic approach of multivariate method. Now, remember in real life, you would not do a linear regression model. You would generally do a neural network, you would generally use a neural network approach. But for this video, I'm just showing you the method of doing this approach, and you should do a neural network in real life. And for those of you who don't know about linear regression model, it simply plots a line y equal to mx plus c. Here b is your c and w is the slope of your line. Learning rate, iterations. Now our original data x and y. These are the equations that you use during linear regression. For those of you who are not comfortable with implementing linear regression, you can use sklearn for doing that. But I would be uploading videos for that in 1 week, in which I would be implementing all the machine learning algorithms by hand and showing you the implementation of the videos along with. For this video, let's consider that this implementation of my linear regression model is correct. And as you can see, if I plot the values that I get using this linear regression model, I can clearly get a straight line through my data. Now, what I want to do is calculate the difference between the generated values and the original values. Now, data 1 here was the original values, and y hat is the values predicted by my model. And now I'm taking the difference of the original values and the values predicted by my model. And then I'm taking the absolute value of that. Of say, if I get -2 as an error value, I convert it to +2. And the threshold for this model, I'm using 2. Now to eliminate the outliers, you simply do a for loop through your data, forward pass, and you do an if condition, if check, error greater than some threshold, you simply delete that value. np.delete removes that value from your np array, and the parameters that it takes is data1, your original array, and the index at which you want to delete the array. Now, if I again plot the data, you can clearly see the outlier was removed. Now, let's come to the next method, Minkowski error. Now, this method is generally not used in real life problems, but still it is worth mentioning because it focuses on a basic approach. When you are fitting most of your models, you use mean squared error, MSE, while fitting your model. Now, what MSE does is if you have, say, error of 10, it squares that error. Now, 10 becomes 100 using MSE. Now, the error that you were initially getting 10 is much, much smaller than the value 100. So, what you can do is reduce the power of MSE to some lower value. So you can do something like say 1.5. You're fitting your model using, no, you cannot say it MSC, but say y minus y hat. You can just do y minus y hat to the power 1.5. So what it will does is it will raise that error value of 10 to 1.5, and now it will be like around 40, which is much better than 100. Now remember, Minkowski error does not remove outliers. It just reduces the effect of the outliers. So this method can be used when you don't want to go into the nut and bolts of removing all the outliers, but you simply want to reduce the effect of the outliers. Like when you are in hurry for deploying a model, for training your model, you can simply reduce the effect of outliers. Now coming to the last method for dealing with outliers. These are histograms. What histograms are? These plot the frequency of your data. So you can say if I'm some value like np dot array 1 comma 1 comma 1 comma 3, and now I'm plotting a histogram for this data. I would have to choose bins equal to, you can say, let's take 40. This value is long, I know. Oops. Oh, sorry. Did not run my initial cell. There we go. Now, as you can see, histograms plot the frequency of your data points. In this data, we had 1 3 times. So it produces 1 3 times. And we had 3 2 times. So these are histograms. Now, how histograms can be used to classify some values as an outliers? Again, coming to the data that we originally had, and random.random, and we added these error values to it. Now, what it did was it all the data that came from the original Gaussian distribution, it classified it correctly. Now, for all the outliers, 80, it is around here, and 95. As you can clearly see from this diagram, the values at these far ends, these are outliers. So you can use histograms to classify these values as an outliers by seeing the difference between the previous values. Like this difference is quite large. So these values may not be following the pattern of this data. So guys, this was it for this video. Wait for the next video. It will be uploaded in 2 days. It will be on how you can choose the number of bins for your data in a histogram. So comment, like, subscribe, guys, and leave your questions in the comments. I